Okay, we left off with doing the addition property of equality. Now we're going to do the multiplication property of equality. And this is essentially going to be the multiplication / division property of equality. So remember from section 2.1 that a linear equation is in the form ax plus b equals c, where the a, b, and c are just real numbers. So if we wanted to solve this example, 3x plus 2 equals 17, we said, let's get all the variables on one side. Let's get all the constants on the other side. So we would, based on the addition property of equality, have to subtract 2 on both sides first to cancel it on the left-hand side. And then we would get 3x equals 17 minus 2, which is 15. Okay, so previously in section 2.1, we were getting all of the variables with a coefficient of 1 on them. This time we have a coefficient of 3. So this says 3 times x equals 15. So 3 times what equals 15? Hopefully we can figure that out without actually having to do the math. 3 times 5 equals 15. So that means x has to be 5. So obviously we're going to be doing this by hand instead of just guessing the answer or just knowing the answer by looking at it, because they won't all be that easy. So the way that we do that is we had 3 times x equals 15. So since we were multiplying by 3, we do the opposite operation here, which was divide by it. So it cancels that. 3 divided by 3 is 1. So on the left-hand side, we're left with 1x, so x. On the right-hand side, 15 over 3, so we get x equals 5. Okay, so that takes us to the multiplication property of equality. So this property says if we have an equation, a equals b, so just something equals something, what we could do is we could multiply c, something else c, some other number, to both sides of the equation, and that won't change it. Or we can divide c on both sides of the equation, and that won't change it. They do have to be non-zero though. Okay, and then a nice little trick here for this second portion down here is instead of dividing both sides by a number, we can multiply both sides by the reciprocal of the number. So recall that instead of dividing by a number, we can multiply by the reciprocal. It means the same exact thing. And another important thing to keep in mind down here is that we can't divide both sides of an equation by a variable, because the variable could be equal to 0, and we cannot divide by 0. So we're only going to be dividing numbers, constants. So some examples here. So let's solve the following equation. So we have 3x equals 15. So this is pretty much the one that we just did. So since we're multiplying, we're going to divide both sides by 3. 3 divided by 3 is 1. So we get x equals 15 over 3, which is 5. Once again, we can check our answers, which I'll just check the first couple here. So that's 3x equals 15. We're going to plug in that 5 in there to x to see if we're correct. 3 times 5 equals 15. That is true. So that checks out. Okay, and then the next one, we have 5x equals 60. So for this one, I'll do it the reciprocal way. So instead of dividing, which either way is 100% fine, sometimes it'll be easier than others, which we'll see in a second. So instead of dividing both sides by 5 here to solve for x, so 5 times what equals 60, we could, if we really wanted to, multiply by the reciprocal of 5 on both sides, which means we would be multiplying both sides by 1/5. So it means the same exact thing. This probably doesn't look as clean as what we just did, but we'll see when we're dealing with fractions, it's a little bit better. So we end up with x equals 60 times 1/5. 60 times 1/5 is the same thing as 60 divided by 5, and 60 divided by 5 is 12. So we get x equals 12 here. And then for the next one, we have 25x equals negative 30. So for this one, 25 times x equals negative 30. Going to divide by 25 to cancel it. So we get x equals negative 30 over 25. We can actually simplify this a little bit. We can cancel off a common factor of 5 in the numerator and denominator. So 30 divided by 5 is 6. 25 over 5 is 5. So this equals x equals negative 6 over 5. And then for this next one, we have negative 7x equals 35. So divide both sides by negative 7. We get x equals 35 over negative 7. That's going to give us negative 5. So just recall that if we're multiplying or dividing, where one number is a negative, the other is a positive, the answer will be negative. All right, so for this next one, it looks a little bit different here. We have, I'm going to rewrite it so I can work with it a little easier. We have x over 4 equals 3. So this is the same thing as 1/4 times x equals 3, if you wanted to think about it that way. So since we're dividing by 4, in order to get x by itself, we need to multiply both sides by 4. Because 4 divided by 4 is 1, so they cancel. We're left with x equals 3 times 4, so x equals 12. Okay, you can check that again if you want. I think I forgot to check a couple of them. X over 4 equals 3. That's 12 over 4 equals 3, which is true. Okay, so here's a good one now. So we have 3/4 w equals 6. So I'm going to rewrite it. Okay, so we need to somehow get rid of that 3/4 on the left-hand side. So this is where multiplying by the reciprocal comes into play. So 3/4 w equals 6. So we would have to divide by 3 on both sides and multiply by 4. We can do that in one quick step by multiplying both sides by the reciprocal of 3/4, which is 4/3. Okay, so it's going to cancel on the left-hand side. So we get w equals 6 times 4/3. So that's 6 over 1 times 4 over 3. So that's going to be 24 over 3, which is going to give us w equals 8. Once again, we can check that in the original if we want. Next one, we have negative x equals 8. So we have two options here. All we have to do is get rid of that negative sign. So recall that if there's no coefficient on a variable, it's just a coefficient of 1. So that's saying negative 1x equals 8. So we have a choice here to either multiply or divide both sides by negative 1, and that will completely cancel it. So I'm just going to divide by negative 1. Once again, it doesn't matter which one you do. So we get x equals 8 over negative 1, which is just x equals negative 8. Okay, and then the last couple here, we have 5m plus 6m equals 33. So we need to combine like terms. So we have 5m plus 6m, that's going to give us 11m equals 33. So 11 times m equals 33. So 11 times what equals 33? Oops. So divide both sides by 11. M equals 33 over 11. So that's m equals 3. I'm going to check this one just because it's maybe not as obvious when you're just looking at the original what the answer is. Some of them are pretty obvious. Okay, so we're going to plug 3 in to see if it works. So that's 5 times 3 plus 6 times 3 equals 33. That gives us 15 plus 18 equals 33. 15 plus 18 is 33. So that checks out. We did it correctly. And for the second last one here, negative 2/5 x equals 10. I'm going to rewrite it. So I'm going to multiply both sides by the reciprocal, so it cancels on the coefficient multiplying the variable here. So the reciprocal of negative 2/5 is negative 5/2. So it's going to cancel over here. So we get x equals 10 times negative 5 over 2. So negative 5 over 2 times 10 is going to be, I'm going to actually simplify this a little bit differently. I'm going to do 10 divided by 2 is 5. So that's going to be 5 times negative 5, so negative 25. So if you're not comfortable doing that in one big swoop, you could do 10 times negative 5, which is negative 50, and then divide it by 2, which is negative 25. So hopefully that made sense. Okay, so for the last one here, we have 9r plus 2r equal, 9r plus 2r minus 7r equals 68. So we have to combine like terms. We have 9r plus 2r minus 7r. That's going to be 11r minus 7r, which is going to be 4r. So we get 4r equals 68. So we have to divide both sides by 4 to cancel that 4. And 68 divided by 4 is 17. So we get r equals 17. Okay, so that's it for 2.2.